That is 3D printed. Now it'd be really hard to make this the usual way that people have always made plastic tools and toys. Usually they'll take a liquid plastic polymer and inject it into a mold that's already made. 3D printing, though, uses kind of a blueprint and then adds pieces of plastic layer by layer. Now this is a very detailed process. It's kind of expensive and it takes a long time, but it's really revolutionary in the world of technology and in manufacturing. Okay, how?
The main advantage, or one of the many advantages of additive manufacturing, would be, as you mentioned, where traditionally to make something, and we would normally start with something like this, for example. You would normally start with a block of stock of some kind, either plastic or wood or metal, and then you actually have to go in and remove the material that you don't want in the final part. And of course in metals you can also liquefy the metal and then pour that into a cast. So that's normally the two of the main ways we would normally make something, is either in a cast or simply removed from a base part. The advantage of additive manufacturing is you don't have to necessarily remove material to make something like this. You can build this, and what it does is it'll build it one layer at a time. And so it'll move, most of the printers we have will start at a base layer, they'll lay down that layer, and they'll move up and they'll make that portion of the part in the next layer, and then it'll move up above that and it'll make the next layer on top of that. And so it just builds one layer at a time, not adding the extra material that you don't need in the final part. So the advantage there is you can actually make moving assemblies in a single print. This is not something that has to be printed or manufactured in 3 separate parts and then later assembled. With additive manufacturing as it is, you can make this in one complete part to start with. And again, there's not a whole lot of way to get in these little tight spaces in here with a tool and remove the material that you don't want. Well, you don't have that with additive manufacturing. With 3D printing or the like, you just make the material you need and not a whole lot more. Now, sometimes we do have to add support material to fill in the empty spaces. But the new modern 3D printers as they are, they're really starting to solve that. And so pieces like this, to where you've got all moving part assemblies, and there are examples of this that we can print this in one single print. You can reduce the number of unique parts that way. You don't have 20 or 30 smaller components that you have to assemble, inventory, keep track of. You just make one component. Another advantage we have sometimes in additive manufacturing 3D printing is there's a technique we call soluble support, where, for example, this particular part, again, it can be printed in a single print. The problem is in between these moving parts, you have airspace, you have a gap. Now, one solution to that is when it's printed, in between the parts, in between the layers, we can lay down, or the machine can lay down a material called soluble support that can then we can place this part after it's come off the printer into a solution of some kind, water, or a lot of times it's an alkaline solution, sodium hydroxide solution. And that will actually dissolve out the support material in between the moving parts, and all that leaves then is just the parts that we actually want, that we're actually trying to print.
All right, I'm here with Brian, and he's going to talk to us about 3D printing, and not just regular 3D printing, but 3D printing with metal. You see some examples behind here. Tell us a little bit about this big thing. What exactly is this?
Well, this is actually a motor housing body. And what we've done with additive manufacturing here is we've been able to run a cooling channel through the internals of the heat exchanger here. And one of the problems with motors is wear and lifespan. And the cooler you can keep the motor, the longer you can increase the life of the parts and the motor itself and increase the efficiency as well.
Now, is this rated for use in a motor, or is it strong enough to be knocked around like something in a car?
It definitely is strong enough to be knocked around, depending on the companies and how they've qualified it, qualified the materials and the machines internally. That kind of depends on whether it's ready for a real-world production environment, such as a car or an airplane or a rocket even.
Now, we've got something really complicated looking right here with a lot of, looks like channels.
Yeah, one of the benefits of additive manufacturing is you're able to actually get organic designs. So, when you're thinking about fluid dynamics, flow, be it air or fluid, 90-degree corners can cause problems, cause cavitation, knock air out of the fluids that you're pushing through it. So by getting organic flow patterns, eliminating those 90-degree corners, again, you can make these more efficient. We've also been able to combine a lot of other items. I think we actually combined about 9 different pieces.
About how long would something like this take to build?
We print about 10 of these on a plate at a time, and you're looking at about anywhere from 50 to 60 hours. I've also got some test specimens on here. So I have a density block, I have a powder capsule, and some tensile bars. And basically after this build is done, we'll cut those off the build plate. I'll send the tensile bars, the density block, and that powder capsule up to my office in New York, and they'll cut it up, they'll polish it, they'll look at the specific density that we're producing on this machine, they'll test the tensile bars for their strength to make sure that we're actually producing good metal off of this piece of equipment, and then we can actually certify it for operation to produce parts.
Great. Well, I see something really cool going on behind you. If we could take a look at that.
Oh yes, dots.
How long would it take how long is this process going to take?
In all, for minus the tensile bars, we were looking at about 20 hours. And that's been one of the issues with this industry, is that the machines are so slow, and again, time is money on these machines. You're paying by the hour on something like this. So the slower a part takes, the more expensive that part is. So the industry is really working to improve that speed. They're implementing higher wattage lasers in the machine, introducing multiple lasers in the machines. At our factory in New York, we actually have about 6 machines that have dual laser setups. So the build plate that we build on top of is actually broken into 2 halves, and one laser takes over one half of the plate, and the other laser kicks in on the other half. So you're building 2 parts simultaneously with 2 different lasers, or you could even have 10 parts, and one laser is working on 5, the other laser is working on the other 5. So you've about halved your build time there.
That interview was a few months ago. We're always on the lookout for something odd, interesting, entertaining, or unusual. If you see something like that in your day-to-day work or your life, or if you see something you think other Oklahomans would be interested in learning about, you can find me on Twitter @Denwalt, or email me ddenwalt@oklahoman.com. I always welcome your suggestions and story ideas. Hope to see you soon.